I am Anil Kumar. Welcome to my YouTube channel and our special summer classes. You can learn these days from home from Anil Kumar. Here is a lesson on for grade 5 students on solving problems using patterns. We'll also understand a particular approach to solve these problems, and we are calling this approach as UMCL model, right? That's very important to understand. During the school, in primary and middle schools, we follow this approach of UMCL. We'll try to understand what is this model which helps us to solve many problems. We'll also see what could be a strategy to pair the numbers so that we could work with them very easily. So that is going to be our next topic. Now, this pairing could be done when we have even number of numbers or we have odd number of numbers. We'll also understand that it is sometimes even easier to add twice than just adding once, and that is very interesting to figure out. Then we'll see patterns in nature and we look into growing patterns. So let's begin with the model itself. So when I'm saying UMCL approach, here U stands for understand, M stands for make a plan. So first you need to understand the question and then make a plan for it. Once you make a plan, C is for carry out the plan. Once you carry out the plan, you're going to get the results. After getting the results, look back, and that is what L stands for. Look back and see what did you get and what you wanted, what was actually required. So all these learnings get into the process of solving further problems. So when you make the next model or the strategy to work with, it is a learning process. Every time, start by understanding the question. Once you understand a question, make a plan and then carry it out, right? And when you get a result, look back and see, does it fit? Okay, so here is a simple exercise to do. Here you can see many numbers on the screen: 6, 5, 9, 3, 4, 1, 8, 2, 5, 7. I want to add them and I want to add them quickly. How can I do it? Well, one way could of course be just add 6 plus 5 plus 9 plus 3 plus 4 plus 1 plus 8 plus 2 plus 5, 7, and then you'll definitely get the result. But there could be some other way also, and that method is what we are going to see here. And that is, you could pair the numbers, right? So how could you pair the numbers? That is what we want to see. Well, if I pair 6 and 4, I get 10. Do you see that? Working with tens is very, very easy. So our strategy normally is to pair the numbers so that we get easy number to work with. 10, for example, is a easy number to work with. Do you see that? So most of these numbers can be paired, and what we get here is 10. Then counting how many tens we have, we could get the result. Let's count and figure it out. So we have one 10 here, right? We get the second 10 here. We get the third 10 here. We get the fourth 10 right there. And one which we left, which is this pair. And that becomes the fifth 10. So when you pair, we have 5 pairs whose sum is 10 each. Does it make sense to you? So it becomes 5 times 10, and that is the number 50. So that is a strategy. So we kind of made a plan, and our plan was, let's try to club the numbers so that we get a sum of 10, and then it becomes very simple. You remember counting change sometimes? Let's say you have a lot of coins. Now we just put a pile of coin so that makes 100, and then you can count the hundreds you have. Correct? So the strategy which we are calling here is pair the numbers to make 10 and then add. So that could be a good example to start with. But let's look into more practical questions. So here again, we'll think about UMCL approach, but we have an example to work with. The example is Use pattern to add all numbers from 1 to 100. Well, that's a big exercise. Now, definitely, when you have to add all the numbers from 1 to 100, you just can't just sit there, even with the calculator, punch in the numbers 1 plus 2 plus 3 plus 4 plus and continue till 100. It will take the whole day. And if you miss any number or you punch in a number twice, you'll get a wrong result. How do we do this? So again, we have one strategy of pairing, right? So we could pair, but how to pair? Well, if I pair these numbers, if for example 1 and 100, and what do I get? Well, I get 101. And if I pair 2 and 99, I get what? I again get 101. Does it make some sense? Yes, it does. Okay, let me try on a small scale, right? So we'll try this strategy on small scale. Small scale means less numbers, right? So let's try it from adding numbers 1 to just 10, for example. If it works for that, then we can look back and apply the strategy with hundreds and so many other numbers. So I hope you get the idea, right? So let's try the strategy. So here we have another sample for you, and that is the same strategy. We want to now add the numbers 1 to 10 and see if it works. So if I combine, as I was saying, if I combine this, I get 110. Is that correct? Yes, I do. And then if I 10 plus 1 is 11, right? So we don't get 10, but we get 11. Right, that is what is expected. 1 plus 10 is 11. Then if I add 2 with 9, what do I get? Again 11. Right? So it is as expected. 3 and 8. What do I get? 11. And now, how about 4 and 7? Again 11, right? What is left with us is numbers 5 and 6, and they also give us 11. Do you see? So how many 11s we have? We have now 1, 2, 3, 4, 5 11s. That means 5 times 11 is 55. So the sum of these numbers is indeed equal to 55. Correct? So that is what the strategy is. So I'm trying to explain here. We understand, and then we understand the question, and then we have to find a pattern to add, right? That is the whole idea. So our plan is to pair the numbers which will give the same sum. And in this case, if I pair, I get the same sum, and that sum is 11, right? So that sum is 11, correct? So let me use a different ink here. Okay, that makes sense. So let me make this as 11 as the sum. So how many 11s did we get? We get 5 11s, and therefore the answer is 55, correct? So we have a strategy. It works for 10 numbers. So I could work this out with even more numbers. So let's get back to our question. Our question was to add the numbers from 1 to 100, right? So how do we do it? Well, we'll have to find a pattern, and the strategy here is to pair the numbers. Okay, so let's pair the numbers and see what do we get. So let's do 1 to 100, and what we get is 101, one more than 100. And then let's do 2 and 99. So we have 2 and 99 is also 100 and 1. And then we do 3 and 98, and that is also 101. So we get so many hundreds and ones. Okay, the idea is to understand this strategy. Now the question is, we are getting 101. How many pairs? That is what you need to answer. How many pairs? How many pairs are there? Well, since we are pairing 100 numbers, it is half of 100, right? So it is 50 pairs, correct? It makes sense. So we know that there are 50 pairs, and that is what I'm writing here. So in our plan, we understand that if we pair the first and the last and then again the remaining first and the last, we get the sum of 101. And since we are combining two numbers, half the number of pairs, right? If there are, let's say, 10 persons and we do pairing, we'll have 5 groups of 2 each. If there are 100, we'll get 50 groups of 2 each. And that is what it means. So basically, we'll multiply 101 by 50. And when we do it, well, because of this 0, I will put 10. Now it is to multiply by 5. 5 times 1 is 505. So I get 50 as my answer. And that's what I got here. So when you do work out even numbers, okay, now we have to look back what we have done. But first, let's write down our result. That we got this as 50, our result. Since there were 50 groups of 100. Is it making sense to you? Correct. That makes sense. Perfect. Now, here there is one important thing to understand. When you look back, what do you see? Well, when we work for even numbers, we have all pairs, right? There's nothing left. But how can we make it work for odd number of numbers? Let's say we have 101, then one will be left out, one will not be able to be paired. Let's take a small scale example. So what I'm trying to say here is, let me say I want to now add the numbers 1 to 11. Then what will happen? Let's see this part first. Okay, so if I add 1 and 11, what do I get? I get 12. Now if I pair the next number, which is 2 and 10, I will get 12 again. Perfect. Now, if I pair 3 with 9, I get 12 again. That is how I'm pairing, right? I know I have to pair like this, right? And 4 is 8 is going to give me 12. Similarly, I can again pair 5 and 7. So we do that and we get 12. What you see here is one particular number, which is 6, has been left alone since we had odd number of numbers, right? So in this case, we had odd number of numbers. Correct. So in that case, 1 is left. So we can now add 1, 2, 3, 4, 5. So we have 5 12s, which is 5 times 2 is 10, and 1 carry 60. Plus, we have a number 6. And when we add this, we get 66 as our answer. So the number in the center will remain. You get the idea, which is half of these numbers, correct? So that is how we should be doing it. Correct. So how many numbers are there between 1 to 11? There are 11 numbers. So 5 pairs, right? So we have 11 numbers. That is like 10 plus 1. So these 10 numbers will actually pair up 5 pairs, right? And one left, one left. Is that clear to you? So that is what we're trying to see. If there are odd number of numbers, the center number will remain, correct? Now these exercises were slightly simple. We took the numbers from 1 to the number, so it was easy to work with. Okay, so let's have another approach to this pairing. Well, this we'll call as method number 1. Here is another particular approach. This approach will try to see, we have to again add the numbers from 1 to 11. Okay, now here the approach is to add twice. In fact, when you pair two numbers, correct? Why not add the whole series twice, right? Instead of pairing, right? So add twice the whole series. We can say set of numbers. Is that correct? Okay, new term set. Group of numbers, right? This is also called group of numbers. So what we have here is we just wanted to add ones, 1 to 100. I flipped the series. Do you see I wrote first 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And now when you add, what do you get? Well, 1 and 11 gives me 12. You know that, correct? And then 2 and 10 also gives me 12. And likewise, we get all 12s as expected. These are all 12s. How many 12s this time we get? We get 11 12s. There were 11 numbers. So we added the whole series twice. Therefore, the sum is 12 times 11. Since we had two series, we'll divide by 2. Correct? Now, it's always easier to first divide and then multiply. 2 goes 6 times. So we get 6 times 11 as our answer, which is 66. So the sum of this series is equal to 66. Do you see how adding twice was faster than adding once? Surprisingly, right? So that is always there if you have a strategy in mind. So we have a strategy, and this can be extended to any group of series like this. Here is a working example for you. Strategy to add twice in reverse order. That is what we did. And now use pattern to add numbers from 1 to 20. So that is what you need to do. So once you do that, post your answers. Correct? Let me give you the answer at least. 1 to 20, when you add 2 and 1, you get 21. Correct? 21. So how many 21s will you get? You'll get 20 of these, and then you have to divide by 2. So you get 210 as your answer. So simple. So it is so fast. Do you see that? That's interesting. So now let's take up some difficult questions, and here are three questions for you. I would like you to pause the video at this stage, answer these questions, and then look into my suggestions. So the very first question here is add the numbers 3 plus 4 plus 5 and so on till 22. The second one is to add the numbers from 4, 5, 6 till 16. And question number 3 is find the sum of even numbers less than or equal to 100. So there are three questions here. I'd like you to pause the video, copy these questions, solve them. Does make sense to you? I'll quickly go through their solutions. Will not really explain them much since it is an exercise for you to do. So in test question number 1, we have to add numbers 3, 4, 5 up to 22. First step should be what? First step should be of understanding what method are you going to apply, because you've understood the question. Question is to add the numbers without really adding them one by one with a strategy, and the strategy we decide is maybe pairing. Okay, that could be the strategy. But now, since we are not starting with one, we have to also think about how many numbers are there, and therefore how many pairs can you make, right? So if you begin with 3 and with 22, there are 22 minus 3. When you do that, it is plus 1 number, right? So there are 20 numbers. So you see from 3, 4, 5, 6 and so on, there are in all 20 numbers from 3 to 22. Both are included. Do you get this point? So there are 20 numbers from 3 to 22, not 21. Some students will do 22 minus 3 to find the number of numbers. You get less number 19, but then you have to add 1 also because both the ends are included, right? If I do 4 minus 3, I get 1, but 4 and 3 are two numbers, correct? So I added 1. If I do 5 minus 3, I get 2, but there are three numbers, 3, 4 and 5. So I added 1. So that is why we add this number 1. This is kind of important to understand after we subtract from here the first number. So that is the strategy to find the number of numbers, correct? So we have now 20 numbers. Divide by 2, we'll get 10 pairs, right? And each pair will be what? Each pair. So each pair will be, when you add these two numbers, which is 3 plus 22, you are going to get 25. Correct? So each pair is 25. So we have how many pairs? 10 pairs, and each is 25. Correct? Does it make sense? So sum of each pair is 25. Sum of each pair is 25 written again. And there are 10 pairs. You'll multiply 25 by 10. Get your answer as 250. Perfect? Okay. Let's look into the next example. If you're not understanding, there is some problem, you can go back and see and then come forward. That's the beauty of these videos, right? It's an advantage. Now try this question. We'll now begin with 4, end with 16. How many numbers are there? That is your first step. Well, instead of doing that, why not add the whole series twice? Okay, we'll do that. So add the series twice in the reverse order is our second strategy. So we applied the second strategy, and so I'm calling this as method number 2. So we have these numbers 4, 5, 6, 7, and so on till 16. I flipped and I started with 16, 15, 14, end with 4. When you add 16 plus 4 is 20, so the sum is 20. Again, we have to find how many numbers. 16 minus 4, add 1. 13 numbers. That means the number in the center is left alone, right? If you pair. But in this case, that is okay. We have 13 numbers and each is 20. 20 is the sum. So the total sum is 20 into 13, correct? So when we have odd numbers, this is a very good strategy. You don't have to worry about the center number. Center number sometimes is very difficult to find. Okay, so we found that when we add, we have 20 and we have 13 of these numbers. Multiply by 20 will give us the sum of two series, right? So that gives you total for two groups, not one, because we added them twice, correct? Two groups. So the total of only one group will be half of this. Half of 20 is 10. So we took 10 here. Do you see that? And multiplication was 10 was easy. 13 times 10 was 130. We got our answer. Did you see that? So that's very tricky. But if you apply the right kind of strategies, it works. So you can summarize here that if we have odd numbers, then adding twice is better. Is that clear? In reverse order, let me write. Perfect, as you have seen. Since we do not have to find the middle number, which is left out, why not pair all the numbers by reversing this full series and then adding them up, right? Okay, here is our last question. We want to find the sum of even numbers. And what are even numbers? Even numbers are numbers which end with multiples of 2. So skip counting. 2, 4, 6, 8, so on till 100. So we have to add all the even numbers in between them. Is that clear to you? How many even numbers do we have? Well, we have 50 even numbers, correct? So I'm going to divide this page into two because there could be two strategies, right? You know, method 1 and method 2, correct? So we'll think about method 2 also. Okay. So in method 1, the idea is to pair them up. So we'll pair them up. When you pair, what do you get? We have 2 plus 100, which is 102. Okay, how many pairs are there? There are 25 pairs, not 50, because we are skipping half of them, right? And therefore, the total is 25 times 102. Is it a difficult calculation? We can do like this. 102, okay, let's do like this. 25 times 100 will do 2500, and then 25 times 2, which is 50. Does it make sense? And we get our total, which is 2550. So that is also a strategy. How do we add? Correct. Now the other method which we learned was to reverse. So we have this series here, so which is 2 plus 4 plus 6 plus so on, let's say till 100. Now if I reverse this, I have 100 plus 98 plus so on and 2 at the end. So if I add them up, I get 102 plus 102 and so on till the last one. Now we have how many of these? Well, we have 50 of these, right? So that comes to be 50 times 50. Now that is the sum of two series, right? Two groups. So one group will be half of this. So it is 102 times half of 50, let me write. Then I'll multiply by 25. So half of this. You could do like this, correct? Which is same as 102 times 25, and which is 2550. Do you see that strategy again? So that is how we could add these numbers. So I hope you enjoyed this journey of learning how to add the numbers with some strategies, correct? In the next video, we'll see how to work with such tree diagrams, and there also will have a strategy to work with. So wait for my next video to get uploaded. That will be critical. I hope you enjoyed this journey of learning about a new model which can help problem solving and enhance your capability of answering and communicating better. That is what is required from each grade 5 student. Feel free to post your comments, and if you like them, that would be great. Thanks for your time and all the best.